Just a second.
Hello and a warm welcome to all our viewers. Welcome to the Vedic Maths Forum India show today. Today we have with us a very eminent mathematician all the way from Melbourne, Australia. And his name is Jonathan J. Crabtree. And he has some amazing revelations about Indian mathematics. Hi Jonathan, welcome to the show.
Thank you very much, Gaurav, and hello to people who might be watching this.
Great. Jonathan, tell me something about yourself.
Oh, about myself. Well, I'm a lot older than you are. 50 years ago, I noticed that India's zero was missing from my teacher's explanation of multiplication. And so when she asked me what 2 into 3 was, she had explained 2 into 3 as being 2 added to itself 3 times. So she asked the class, what was the answer to 2 into 3 if it was 2 added to itself 3 times? I put my hand up, she chose me, and I said 8. And she said, no, it's 6. Now, I was confused because how could 2 added to itself 3 times be 6 if 2 added to 1 3 times was 7? Okay. Now, my teacher then went to the blackboard to show me that I was wrong. And she went 2, 4, 6 on the number line. She did 3 hops of 2 to prove that 2 into 3 was 6. But where did my teacher start 50 years ago? She started at 0. So I noticed that the definition of multiplication was wrong when I was in class 2 in 1968. So the correct way my teacher should have asked, who can tell me what 2 into 3 is, it's 2 added to 0 3 times,
Right.
not 2 added to itself 3 times. So 2 added to 0 3 times is 0 plus 2 plus 2 plus 2, and that gives you 6. So that's what got me annoyed by mathematics 50 years ago.
Tell us something about your journey into Indian mathematics and even Vedic mathematics.
I decided to fix mathematics on Friday, March the 18th at 1 p.m. And that was when I broke my back and I was told that if I moved, I might never walk again. So what I decided to do is if I was able to walk again, I'd need a miracle. And so I made a promise to God, if I can walk and have children, that I would fix mathematics. So my journey into fixing mathematics began 35 years ago in the intensive care ward of a hospital. So when I got out of hospital, I then set about trying to learn about mathematics. And in about 1983, towards early 1984, I read Figuring, The Joy of Numbers, and I also started to learn about Vedic mathematics. And I found it fascinating. I didn't know anything about the vertically and crosswise or the other, the 16 sutras and so on. And that's what gave me the confidence to start exploring alternative mathematics. So then, from that starting point of looking at the Vedic mathematics in about 1984, I then started to look at all the different types of mathematics from different cultures, different languages. And so here I am in India, having rebuilt the foundations of mathematics, the very simple foundations of mathematics, and I've basically thrown out everything that's been developed post-colonization around the world. And I'm starting from the 7th century mathematics of Brahmagupta and rewriting the definitions of mathematics so everything makes sense.
So you already have had a successful tour in Kolkata in the last 7 days of the last week. You've been speaking at various platforms, various forums, where even newspaper articles are covering about your research which you have done and the revelations which you have got by studying Indian mathematics. So tell me something you wanted to relaunch Indian mathematics. So tell us something about that, and even the Brahmagupta. Uh,
Well, Brahmagupta, like many Indians in ancient times, he was fascinated by the stars. And Brahmagupta, like Aryabhata before him, was an astronomer. And they were astronomers, and they needed mathematics to be a tool for the astronomer. So they weren't mathematicians first, they were astronomers first, and they were developing the mathematics in order to calculate movements of the stars for religious reasons as much as anything else. So Brahmagupta, in the year 628, wrote a famous book, and in that book had chapter 18 on algebra. And that's the oldest book that the world has that details all the laws of positives, negatives, and zero. Now, what I've done is I've looked at Brahmagupta's writings in the Sanskrit, and for about the past 6 years, I've been trying to decode how to translate the Sanskrit of Brahmagupta and his laws of positives, negatives, and zero into simple ideas that children can understand. So it's one thing to have the ancient Sanskrit, and many professors have translated the Sanskrit, but it's always been at a very advanced adult level of conceptualization. What I wanted to do is to think, how would Brahmagupta have explained mathematics of positives, negatives, and zero to his own children? And so, because I don't have any advanced mathematics training myself, I've got no mathematics education after I left school, but I've been self-taught. So I think that the beauty of Brahmagupta is he wrote the laws, and all we have to do is obey his laws, which I've documented. There are 18 main ones, a little bit like the 16 sutras of Vedic mathematics. There are 18 main laws of Brahmagupta. And by following his laws, you realize that there's a lot of rubbish in Western mathematics. So, for example, one of the things that's a load of rubbish is that negative numbers are less than zero. So, by way of example, the ancient Chinese had negative numbers for about 1,400 years before they got India's zero. So the ancient Chinese never would have said negative numbers are less than zero because they didn't have zero. And they only got zero from the Indians in around about the year 1247. And if you look at common sense, a lot of the things don't make sense. Why would negative 3 be greater than negative 7 when a debt of 300 rupees is less than a debt of 700 rupees? So Brahmagupta defined zero in a very different way to what the West understands. The West understands zero by subtraction. You've got 5 minus 5 gives you 0. And people assume that was the Indian definition of zero as well, because it seems logical to us now. But Brahmagupta defined zero by addition. And Brahmagupta said 4 positives and 4 negatives, in fact, I'll put it the other way around, 4 negatives and 4 positive sum together to make zero. So Brahmagupta's mathematics was a very symmetrical concept. It was very symmetrical about zero. And equal numbers of positives and negatives cancelled each other out to make zero. So there's a long story here, but what I've done is I've looked at the diagrams of Euclid, I've looked at the laws of Brahmagupta, I've then basically played a lot with the ideas of Descartes and Isaac Newton and all of these other people, and they've all led back to Brahmagupta being the golden rule book of mathematics. So I suppose it's a difficult thing to explain just verbally, but there are many simple games that children can play with reds for positives, blacks for negatives, and they just follow the laws of Brahmagupta, and then they're solving mathematical problems by playing a game. And it just makes the idea of dealing with negative numbers really simple for the first time.
Wow, because I think this was the first time in my experience that I am hearing somebody saying that the laws of Brahmagupta can be made relevant to, say, an 8-year-old or a 9-year-old, right?
Yes, absolutely.
Can you give an example of you said did that?
Well, I guess the simplest example is if we had, for example, asked a child, what's negative 4 plus positive 7? The child would be quite frightened at the idea of adding a negative number and a positive number. But just imagine for a moment that we were a young child with a bucket and a spade at the beach. So we go to the beach and there's lovely hard flat sand. And what we do with our spade is we dig a hole and we fill up our bucket. So we've got one hole and then we've got one block of sand because we've got a square-sided bucket. So that can become a metaphor for one hole is one negative and we've got one block or brick of sand is one positive. So then we can just imagine, what if we dug another hole at the bottom of that hole and dug and dug and dug? And what if we dug 7 holes deep? Okay, well that can be negative 7. Now what if we then put our blocks and had a pile of blocks that were 4 high? So we've got positive 4 because we've got 4 blocks going up, and we've got negative 7 because we've got a hole 7 deep. Now the children would love to actually see the fun of moving that block of 4 bumps and then dropping them into the hole and seeing 7 bumps dropped into the hole 4 deep. And then they see that there's 3 remaining. And so what they see is positive 3 as a result of adding positive 7 plus negative 4. So if you actually start to do cartoons with animals and do fun and games, then children get these very simple ideas that reflect physics and the laws of Brahmagupta.
Wow. That's profound because this is taking the ancient wisdom that we have all the way to the new generation which we are going to have. And you're doing a fabulous job because I've never seen any mathematician so far taking these knowledge from ancient wisdom right to the grassroots level.
Yeah, well, I've got to say that I think that it's one thing to take Brahmagupta's Sanskrit text and to understand it. A lot of people have understood his laws. But I think that the goal that I've got is I'm partnering with AFX Animation in Kolkata. And what the goal is by the end of 2020, the goal is to give every child in India a set of free picture storybooks with cartoon animals. And the animals will be doing fun things out there in the jungle and in the desert. They'll be solving mathematical puzzles using the laws of Brahmagupta. So if you think of the Lion King and you think of Simba, well, they're similar to the animals that we'll have in our stories as well. And everybody loves a puppy, so Pogo the puppy will be the lead character going out to solve puzzles involving quantities and counts of quantities and measures. And what we'll be doing is there'll be stories about Brahmagupta's laws. We're not going to mention Brahmagupta. We're not going to be doing a lot of numbers in the picture storybooks, but that will be up to the parents and the teachers to count the things and then start to write equations based on the stories. So I loved cartoons when I was a little boy, and I think that's the best way of introducing Brahmagupta from the 7th century and making him relevant to the children today. And I believe it's possible that many children will become very confident with positives and negatives before they even start school.
How has the mathematical world, your contemporaries, taken to this idea which you have got about your discoveries?
Well, I've got to say that the academic world has been very, very supportive. I have had so much help from professors around the world. I speak one language, but I've done my research out of Latin, ancient Greek, Sanskrit, Arabic, Hebrew, French, German, Italian, Russian, Dutch, Czech, Spanish, Japanese, Mandarin, and there's about another 4 languages I've had to do translations from. Now, I don't speak these languages, but what I was doing is I was sharing ancient manuscripts and old books that I'd found, and I'd write to them. I've got about 17,000 LinkedIn connections. So I've got thousands of people in mathematics faculties around the world that I can choose from. So I don't think anybody else has been so crazy to explore, for example, the definition of multiplication, a very simple idea. I've explored that in 18 different historical languages. So I've been looking at the evolution of mathematics from really ancient times of ancient Egypt, ancient Greece. I've looked at the Shilpa Sutras of ancient India, their sacred geometry. But I've brought it all down into a series of ideas that, remember I told you 50 years ago I was confused by my teacher?
Right.
I've always wanted to create a mathematics framework or foundational, elementary foundations that a 7-year-old child would understand. So over the last 35 years, my target audience has been class 2 children because that's where I first got confused in mathematics. So I've had a lot of help from professors and a lot of encouragement. And it was probably maybe about 5 or 6 years ago that I first started to be quoted in mathematics books. And I was blown away that a professor of mathematics who used to be the president of the London Mathematical Society, Professor Alexander Borovich, he said he wanted to use my ideas in his mathematics book. And I didn't understand why he'd want my ideas because I don't have any qualifications, but he was saying what I was saying was profound. So that went into a mathematics book. I then started to get lots of professors saying, Jonathan, don't email us this information, start writing articles. So I began to write articles, and then I began to do conference presentations. And I kept on finding again and again that people never knew about the mathematics that I was uncovering. So it's just got to the extent where I've been given so much encouragement and I've done so much hard work that I've basically felt like I failed maths at school, but now I have failed everyone in the history of mathematics except Brahmagupta. And there's been lots of wrong translations that I've discovered. But essentially, it's just been my hobby. It's been my passion. I've been absolutely besotted by this puzzle of why doesn't mathematics make sense to me? And I thought I was stupid, but I think that anyone out there who has been confused by mathematics, it's not you. It's the structural foundations of mathematics that are actually currently illogical and lead to paradoxes and contradictions that are resolved by Brahmagupta's laws.
That's fascinating, very profound. How has your journey been in India this time? And do you have a message for your students out there who would like to study your work and follow your passions and your calling?
Well, over the last few days, I went down south to Andhra Pradesh and I did a tour of the three Prakash educational institutions. And in 2 days, I taught 558 class 7 to 9 students. And I said, the ideas I'm going to share with you are going to be different to the ones that your teachers have been teaching you for several years. But the ideas that I'm going to be sharing with you are Indian ideas. And the ideas that you've been learning are actually Greek ideas that were developed in England in the 16th century. So the ideas that your teachers have been sharing with you are based on ancient Greek mathematics from the 4th century BC as interpreted by England in the 16th century. So we've got England versus Australia. England versus India. And I asked the children, I want you to just tell me, which mathematics do you like better? And after the classes, and the first class I did with, I think it was like class 7 children, I had 200 students in the class, and the lecture went for 2 hours. And the children were able to pay attention the whole way through. And at the end of that class, I said, okay, so who likes the mathematics that you currently are being taught? The English way? Or who likes the Indian way? And they all voted they wanted the Indian way. Now that was after one lesson. They were able to pay attention for 2 hours because it was fun and they could follow what I was saying. And it was new and it was Indian. So that was amazing. I mean, that really surprised me. But everywhere I've gone, the children have understood exactly how to multiply negative into negative to get positive. And there's one point in my talk where I put up a mathematical proof of why -1 into -1 is +1. And it's from an article I wrote in the mathematics journal about 3 years ago. And so I know it was a difficult proof to prove because I had to come up with it. And I showed those children in the classrooms how to prove -1 into -1 equals +1 in 10 seconds. And the mathematical proof that those children learned is a deeper mathematical proof than has ever existed before. And it literally takes 10 seconds to learn that proof. And it's a visual proof, and it's a very simple diagram. And as soon as you see that diagram and that proof one time, you understand why, of course, it can only be +1. It's a consequence of the definition of multiplication that I've put together, which now works correctly for the first time in history, based on Brahmagupta. So I'm actually listening to myself say this, and I'm thinking I'm sounding a bit like a crazy person, but it's actually true. What I'll do is I'll actually explain that proof. Okay, now for a start, we don't know the correct definition of multiplication. Since February 1570, we've got A into B has been defined as A added to itself B times. So 1 into 1, by the definition of multiplication for centuries and in the mathematics dictionaries, A into B is A added to itself B times. So 1 into 1 equals 1 added to itself 1 time, which is 2. So the definition of multiplication has been wrong. A into B equals A added to India's 0 B times. Because now our concept of number begins at 0, but in the 16th century, they didn't really consider 0 a number. So, -1 into -1, if you convert that into the logic of Brahmagupta, that means -1 subtracted from 0 one time. Okay, now 0 equals 1 positive and 1 negative, because together they become 0. So if you've got 0 defined as 1 positive and 1 negative, and if you take away the 1 negative, you're left with the 1 positive. And that's the mathematical proof of why -1 into -1 leaves +1. You need to have the correct definition of multiplication first, which A into positive B is A added to 0B times, and A into -B is A subtracted from 0B times. Now, we don't have these definitions in the dictionaries because we're following an incorrect translation from ancient Greek mathematics that was done in February 1570. So it's just been, the history of mathematics has actually been mistake upon mistake. But what we do is every time there's a bug in the operating system of mathematics, they'll invent a law or a rule for you to memorize because they can't explain the mathematics. So they'll say, memorize this law, and that way the numbers will work out. Well, with the laws that Brahmagupta have got, they're very simple laws to follow, and then straight away you get the foundations correct, and then you just use his laws like a tool to solve problems. I can't do this, so I'll use this law to solve the problem. It's a little bit like the 16 sutras of Vedic mathematics. You actually pick and choose which one you need to solve a problem. It's the same way with Brahmagupta.
How I take you back home to Melbourne. Have, how have the students out there taken to Indian mathematics or even Vedic mathematics in Melbourne?
Look, I can't really answer that question about the popularity of Vedic mathematics in Melbourne. I know that when I began my time of research into mathematics, I don't think there was really anyone really promoting Vedic mathematics in Melbourne. Certainly, I read books about it, but I didn't see any courses available on it. And this is where I'll give Gaurav a plug. I actually bought his series of DVDs quite a few years ago, probably because there weren't any courses back in Melbourne. So I think that there's a huge Indian community in Melbourne now, especially in the western side of Melbourne, and I think that outside of India, Melbourne might have one of the largest populations of Indians. And I know that my youngest son, he's doing a PhD in quantum computing at the moment. A lot of his colleagues at the university are Indian. And I also think that some of them are from West Bengal because they speak Bengali. So I can't quite answer that one about the popularity of Vedic mathematics in Melbourne, just because I don't know. But I know that there are a lot of people who are frustrated with the way mathematics is taught at the moment in schools.
Yeah, because what I see is that university levels globally is going down, and India is not alone to the problem. India currently ranks 72 in the world rankings of countries found on PISA or TIMSS. So I have a last question for you: is any message you like to give, any quotes you like to say? How any quotation which inspired you in the past?
Well, I think that the quote that's inspired me the most, I mentioned to you over lunch, is the people who are crazy enough to think they can change the world are the ones who do. And a lot of people over many years have thought I might be a little bit crazy, but maybe I'm just a little crazy enough to change the world.
Thank you so much, Jonathan, for being a guest tonight at the Vedic Maths Forum India. And I wish you the very best. I hope that your message is taken in the right hands in the ministry so that it is implemented in the main curriculum in India at least, and it goes around the world.
That would be wonderful. Thank you very much.
Thank you so much.
Thank you.
Thank you. Have a nice day.
Thank you.
Thank you so much, everybody. And we'll see each other very soon, maybe next week or a Facebook Live. Thank you and have a great day ahead. Thank you.